Okay, so lesson 4 today should be mostly review.
I will give you about 5 seconds.
So we're going to go through this pretty quickly. This one is probably the most review topic out of all of them, so maybe that's good. It ended up on a Thursday. So there are a bunch of different types of equations we're going to look at today. The first type is linear equations. Okay? Linear equations are the easiest to solve, and you can see by this example, you just want to get x on one side, everything else on the other, and get your answer. Okay? A linear equation at most can only have one answer. Okay? So one thing you need to know is that answers are x-intercepts. How many x-intercepts can a line possibly have? Okay? Just one, unless of course it is on the line. Okay? Now, the next type. So linear equations is grade 10. Do a lot of linear equations. Grade 11 and grade 12 is quadratic equations. Your quadratic is going to give you the parabola. Okay? Now, the method you always start with is by inspection. So remember what two things add to give me B and multiply to give me AC when it's a type 2, right? One thing that will actually never fail you is the quadratic formula. Okay? So the quadratic formula, a lot of people think, oh, we just use that when it's not factorable. Actually, it works all the time. Okay? And I remember when I was in high school, I just had that programmed in my calculator, and no matter what quadratic it was, I put in A, B, C, and it gave you the answer. Okay? A couple disadvantages of that in 31 is A, you do not get to use a graphing calculator, and B, you have to clear your calculators anyway, so you'd have to reprogram that formula in. It would actually take you, for the one question on the test that you're going to see a quadratic, it'd probably be easier just to do it with your calculator. Okay? But some students think, oh, that quadratic formula, you only use it if it's not factorable. No, you can use it all the time. Okay? So, and I'm going to do some examples with these. So you can see there's examples that come with them, but because of time, we're going to just do examples on the last page that does all of these. Now, the complex equations are radical and rational. Okay? So the radical, you always want to get it by itself or isolate the radical. So get radical on one side and get all the other stuff on the other, and then you square both sides. Again, we will do an example on the back page so you see what I'm talking about. Okay? Case 2, rational expressions. Identify the NPVs, the non-permissible values. And these values make the denominator equal to 0, and thus the fractions are undefined. Convert both sides to LCD, equate the numerators, and check your answers that are not NPVs. Okay, this is a big deal because if your answer is an NPV, then it's not an answer. Okay, and that's a diploma type question that students who do not do NPVs, they just do that. Students always ask, do we have to do NPVs? Do we have to do NPVs? Well, kind of important because if you get an answer and you haven't done NPVs, you'll probably say that's the answer. And that's what they're trying to catch you on the diploma. Will you check? Okay, so do you always have to check them? Only if you want to get them right. Okay, which examples do I want to do? Okay, I want to start with, hold on here. Nope. I have different examples than you. Oh no, let's start with example 2. Okay, everyone there with me? We're going to try to be efficient with our time. Now this is a quadratic, right? You can see because of the x, or no, sorry, not a quadratic. We've got a cubic with an x cubed and an x squared in there. So this one, anyone have any ideas how to even start solving this thing? Yeah, get it to equal 0. Okay? So you want a minus 9x and you want a plus 4x squared. And it's nice to put it in order of degree. It just looks nicer. So you get x cubed plus 4x squared minus 9x minus 36 equals 0. See, when you make it equal 0, those are your answers. Those are actually your x-intercepts. Because x-intercepts are the answers in graphing, okay? That's how you can solve it, by graphing. Okay, now what would you do? Group. Very good. Okay, so group this set, take as much as you can out of the first set, which would be x squared. That's the best we're going to do, leaving me with x plus 4. Okay, next one, take out a negative 9, leaving me with x plus 4. Look at that. Doesn't that work out nice? Okay, what is common is x plus 4. I'll take that out, leaving me with x squared minus 9. And then that's screaming difference of squares. So that would be x plus 4 times x plus 3 times x minus 3 equals 0. Okay, so x equals plus or minus 3 and 4. Okay, negative 4. Okay, sometimes I get going on the next thought before I actually do the... Oh, sorry. What happened here? My example's wrong in the book. It is negative 4. Check that. Okay, so I guess this one is done by grouping. Okay. Now, next one. Okay, now this one kind of, is it too similar to the last one? No, it's not actually, because it's a pretty mean question. This one, we're going to start the same way. Let's get everything on the left. Minus 4x squared minus 5x equals 0. Okay, again, we don't really want to do grouping because there's not 4 things, right? But we can take something out, and that would leave me, I can take out an x. That's the best I'm going to do, leaving me with 2x squared minus 4x minus 5. So I want to do this one because we haven't used the quadratic formula this year. You know, again, you can try it. What two things add to negative 4 multiplied to negative 10? And there are 2 numbers, but they're not nice, right? And they would not be able to, you wouldn't be able to do it by guessing. Okay, so that's where we're going to use our quadratic formula. Now, I find it nice to label all of my, just remember the negative 4 is my B, and the negative 5 is my C. Okay, and we haven't used it yet this year, so let's just write it down. It is on your formula sheet. Negative, good thing I'm taping. B squared minus 4AC all over 2A. Okay, so X is now, B is negative 4, so negative 4 is positive 4, plus or minus. B squared, that'll always be positive, but let's just substitute the brackets to make sure. 4 times A is 2, and C is negative 5. And remember, that entire equation is over 2 times 2, which is A. Okay? Does anyone remember what this is called underneath the square root sign? More specific, actually, when it comes to quadratic formula, it's called the discriminant, because this discriminates what's going to happen. If this is 0, do you understand we'll only get one answer? Because 4 plus 0 divided by 4. If this is any positive number, we're going to get two answers. Because 4 plus, I don't care what it is, divided by that, and 4 minus, whatever that is. And when we will get no answers is when this is negative. And that means the graph actually doesn't go through the x-axis. Because the x-axis, anything intersecting the x-axis is the answer. Okay? So, just remember that is the discriminant. Oops. Okay? It does help you discriminate one answer, two answers, or no answers. Okay? So this does work out to be x is plus 4 plus or minus the square root of 56 all over 4. Okay? Is there a nice square in 56? What's 4 times 14? This is 4 times 14. Because 8 times 7, 4 times 14. So the 4 comes out to become 2. So you get 4 plus or minus 2 root 14 all over 4. Now if you're going to reduce, all three of these must be reducible by the same thing. If one of them is not reducible, all of them are not reducible. But every one of those can be divided by 2. So if I divide each of them by 2, that will be 2 plus or minus root 14 all over 2. So when you look at this, this would be x equals 2 plus root 14 all over 2 and 2 minus root 14 all over 2. This one's really tricky though, because that's not our final answer. X also equals 0, yes. Because, remember we took out an x right at the very beginning? And 0 makes this all side equal 0. So 0, or if you put 2 plus root 14 over 2 in this, it'll make it equal 0, or 2 minus root 14 over 2. And you won't have, the backup of a graphing calculator to y1, y2, and then see if it's the same decimal. So that's one of the main things that makes it much more difficult than 30, is that you don't have that to fall back on. Yeah, you can check it by plugging it in. Yeah, it's not the most efficient way, but definitely will tell you if it's right or wrong. Okay, any questions? We're all good. Okay, let's do two more examples. Hopefully we'll now. So we've done a grouping one. Okay, we've done one with using the quadratic formula, and this one is that one to be able to show us how to be able to solve when you have square roots. The first thing you want to do is isolate the square root. Left, right doesn't matter, but if we minus 1 to both sides, I will get root 2x minus 3 equals x minus 3. Okay, now this is kind of a nice one because sometimes there's two radicals. So you got to work with one, then you get this atrocious mess on the right, but you get rid of that one. Then you're going to have to do it all over again by getting that radical mess that you had on the right. You got to get it by itself, then you square again. Okay? So this one, we'll square it. And then I get 2x minus 3 equals Okay, it should be x squared minus 6x plus 9 when you FOIL that out. Remember? X minus 3 times x minus 3. Now, for same way we've always done it, let's get it to equal 0. I think for convenience, it's easier to put it all on the right this time. So I'm going to minus 2x, and I'll add 3. So then I will get x squared minus 8x plus 12. Okay. Two things add to negative 8, multiply to give me 12 will be negative 6 and negative 2. So this 0 equals x minus 6, x minus 2. So we're not done yet. What makes the thing equal 0? When x equals 6 and 2. The catch on when you do square roots, when you do rational, the catch is make sure it's not an MPV. The catch when you do square roots is check them because there's a good chance both of them or one of them may not even be true. Okay? Because when I square both sides, it actually can affect the outcome. Okay? So right now you're looking at me like, what are you talking about? So let's try checking 2. Okay, so if I put 2 in there, square root 2 times 2 minus 3 plus 1 equals 2 minus 2. Okay, 2 squared minus 3, that's 4. Minus 3 is 1. The square root of 1 is 1. So 1 plus 1 equals 0. 2 equals 0. No. Okay, so 2 does not work. 2 is not a solution. Let's try 6. 2 times 6 minus 3 plus 1, 6 minus 2. 2 times 6 is 12. 12 minus 3 is 9. Square root of 9 is 3. 3 plus 1 equals 4. 4 equals 4. This one does work. Okay, so x does equal 6. So when you do these, just always check. Oops. Okay. Again, if you took 30 last semester, this is all pretty review. Okay, this one here, this is a little bit nicer than the ones we've been doing before because these are equations, and when they're equations with x's in the bottom, you can get rid of all of the denominators by multiplying by a common denominator. Now, common denominators can get out of control because a lot of people just multiply all three denominators together, put it on the side, and then they just multiply that each one. It turns out this atrocious mess that will take you twice as long and may have twice the errors because you had to do so many steps. The thing that we want to do is factor the bottom. And this one, as you see, if you factor this one, it's x plus 4. Okay? So what's nice about this one, it didn't look like it, but it actually has the common denominator in it. So that side is not going to be that messy. But my common denominator should be x times x plus 4. So you want to multiply each by x times x plus 4, x times x plus 4, and x times x plus 4. Now, you couldn't do this when we did them before because they did not equal anything. When they equal, you're allowed to do this, and now you can actually cancel top and bottom. I can cancel this x with this x. I can cancel this x plus 4 times this x plus 4, and I can cancel this with all of this. Okay? So now I got rid of all denominators. Now there's different ways to go about this. I do find this the simplest. Now, that is 2x minus 1 times x plus 1 minus x times x plus 1 equals just 5x plus 8. So it cleans it up pretty nice. Oh yeah, what am I doing here? No, 2x. Oh yeah, I just can't read my own writing. That's a 4 there. Okay. Now, let's get rid of some brackets. So I'm going to FOIL the first set. So that's 2x squared plus 8x minus 1x minus 4. Be very careful with this one. Remember, I get the negative x in, right? So that is minus x squared minus 1x equals 5x plus 8. Okay, so we can group on the left, because I got a 2x squared minus x squared, which is 1x squared. I got, so they're gone. 8x minus 1x is plus 6x minus 4 equals 5x plus 8. Okay. By this stage, most people are seeing that we're coming to the end here. I do, once again, want to make this all equal 0. So I'm going to subtract the 5x here. Make sure I do to that side. And minus 8. So x squared plus x minus 12 equals 0. Okay, two things that add to give me 1 and multiply to give me negative 12. Would be 4 and 3. So x equals negative 4 and 3. Okay, again, not so fast. List all your non-permissibles. They are, so non-permissible values are 0, negative 4. Therefore, okay, so the answer is x equals 3. Okay? So, yeah, this should be a lot of review. So 3, 6, 7, 9, 11, 13, 19.